welcome back. If you are new, my name is Dave Thomas, also known as fsharp9. This video is going to be another in the monogame F-sharp series, and there's a few different things that we need to do before we can progress this into a true platform game. You might have noticed that the skeleton that we've been moving about and animating on the screen is actually in top-down view. The reason for this is it's easier to manipulate and animate sprites without having to think about collision detection, platforms, and things like gravity. But first we need to consider several different things. We need a camera to know where we are within a level. We also need to draw the background, any platforms that the player is going to be on, and also we need to simulate some aspect of gravity. So in this episode we're going to look at the camera and apply it to what we have so far. Now I think I need to go and make a cup of tea before we get started. So you all might be thinking, the camera, this has got to be pretty simple. Well, if you look through the history of some of the different video games, the camera can be extremely complex. Like take Sonic, you can see that the camera is snapping on a per platform basis, and there's also a small amount of movement allowed in the vertical axis. You take another game like Strider, this kind of follows the player pretty smoothly in the center of the screen. Each game has kind of got a slightly different way of doing the camera, and it can be a quite complex area. If you take another platform game like Castle of Illusion, again this has got a follow camera as usual. Well, there's a lot of slack in it, so you can kind of move into a space before the camera actually tracks. So if you can imagine like a large rectangle, when you reach the bounds of the rectangle, then the actual screen scrolls. Let me take another fast action game like Contra. This is different again. It's kind of like a variable speed camera. It tracks the players, especially if there's two players, it kind of tracks the player's position in the game levels. Finally, you've got cameras for games like Thunder Force 3, where the camera will be always moving through the level, perhaps with parallax scrolling, and you can orientate yourself within that particular camera, but the camera's always fixed and always scrolling. The thing to bear in mind is that camera can be potentially a very complicated thing to control and very difficult to get right. So the first thing that we're going to do is we're going to scroll down, and first of all, I've added a couple of things here. I've added the dimensions of the viewport to a standard HD screen. And now we're just going to quickly create a nice camera it's going to be very simple. It just tracks the player's position and orientates exactly center on that. We're going to create this in kind of a traditional manner to keep things really simple here. We're going to create a standard type. We're going to add various properties to this. A matrix for the world to screen transformation, a matrix for the screen to world, a zoom, a position, and a rotation. The next thing we're going to do is define a member called update. We're going to take the position of our character and we'll mutate the position variable, and then we'll create the world to screen matrix. For this, although it looks quite daunting, it's a fairly standard procedure once you get used to it. What we're doing is we're taking the character's position and we're creating a translation based on the inverse of that. If you think of the camera's point of view, is the player's position is the inverse in relation to the camera. And after that we create a rotation, which is going to be 0 because we're not going to be doing any particular rotation. Our scale Again, we set this to a standard 1 scale because we don't want to do any scaling at present. And then we create a final translation, which is basically making sure that the player is centered in the screen. So our translation is based on half of the viewport width and height. And to do the opposite of this, which is to translate from the screen to the world, we just create a simple matrix inversion. The last correct translation is a little unwieldy, so let's do a little bit of refactoring. We'll create a extension to the monogame viewport type. And what we'll do is we'll create a center property for this, and we'll use the functionality we defined in the last translation. And now we can strip all of this out and replace it with a simple vector 3 using the extension that we created above. The next step is actually using the camera, so we'll scroll down to where we initialize the variables and we'll create a new camera here. Now we move to the initialize function where we actually initialize the camera. This has to be done in this section because the viewport isn't actually initialized until the initialize function is called too. If we scroll down, and we can get rid of this old code from the previous video. Now we can begin by updating the camera. Well, actually, we need to move this after the new player update because we need the new player's position. So I'll just cut this and move it down. We just have to add in the new player's position. The last thing we need to do is to modify the sprite batch operation to pass in a transformation matrix. This will allow the entire batch operation to use the same matrix to transform all of the particular draw operations. We use the nullable op implicit again because the transformation matrix is nullable. Now we can go into debug and give this a whirl to see what happens. So now you can see the skeleton at the center of the screen, and when we walk, nothing appears to happen because we're tracking the player right in the center and we're moving the camera in accordance with the player's position too. So let's see if we can do something really quick to make it obvious that the player's moving. We can do that by uncommenting out the original player draw. And now when we move our skeleton, you can see the original player's fixed and we're actually walking around it. And if you look, when we move left and across to the right, we're hitting an invisible boundary, and this was the previous view extent that we were using to limit the player's motion. We can look at fixing this when we get to actually drawing the background and creating a world to draw to limit the player to. I'd just like to take this opportunity to thank all of my patrons that are supporting me on this channel. It's very much appreciated. At the weekend we had the first live stream for the top tier patrons, and in the live stream we built, it was an implementation of hot loading so that when you're actually modifying the code in the game's actually running at the same time and it automatically updates. We didn't get it completely running, but we got it almost there, and in the week after, like this week, I managed to get most of it working. So I'm going to continue to build that out, and hopefully in one of these videos in this series I should be able to present the code and work through that and how it works too. So if you got this far, why not consider subscribing to the channel, hit the bell notification so you know when a new video is out, absolutely smash the like button as hard as you possibly can, and I will see you next time.